Hi, I'm Chris, and I'm excited to show you the Bounce toolset from my new Anim Toys tool pack for Blackmagic Fusion. The Bounce tool allows you to create bouncing animations with customizable squash and stretch characteristics with options to rotate your image in sync with the bounces. To get started, I've put together a very simple comp with a smiley face merged over a black background. I've added a bounce tool and zeroed it out so we can look at each control one at a time. Starting with the basic bounce section, these controls let you set up the main properties of the bounce animation. The starting height allows you to set how many pixels the image will fall before it bounces. If we jump down to the Show Bounce Container button and select that, the outline of the box that the bounce tool uses for its calculations will be displayed. Now going back up to the starting height, if we set it to 0, we'll see that our smile is sitting right at the bottom edge of the box. That's the baseline of the bounce. The starting height control sets the number of pixels above this height we want to essentially drop the image to start it bouncing. I'll start it at 800. Now we have a bouncing smiley. The gravity control sets the acceleration of the system. The gravity always works in a downward direction, but of course you can transform the animation to change the angle of the bounce. Okay, I'm going to undo that. The 0.05 value is already pretty strong, and you can choose a much smaller number if you want a more floaty feeling. I'll put it back to the 0.05 value. The bounciness value is sort of the opposite of the gravity. It sets how much of the previous maximum height the next bounce will get to. Currently, it's set to 1.0, which means that every bounce will maintain the full height of the previous bounce. As I lower the value, you see that subsequent bounces are reduced in height. If you want a really dead feeling bounce, you can set the bounciness to a low number like 0.1 or 0.2. I'll put it to around 0.8 for now. Threshold bounce frame lets you control how short you want each bounce to get before bouncing stops completely. Our current bounce animation gets to a point around here where the bouncing gets pretty quick. If you don't want that, you can raise the threshold bounce frames to stop the bouncing earlier. If I set it to 5, you'll see the bouncing stops much earlier. What's happening is that each time the image reaches the baseline, the bounce tool looks to see how many frames it will take for the next full bounce motion to complete, and if it's less than the threshold bounce frames value, it stops the animation. We've already looked at the Show Bounce Container button. I've found that having this on can be useful when trying to precisely position your bounces, but I'm going to go ahead and turn it off now. The squash and stretch sections allow you to control how your image will be deformed during the bounce cycle. The squash controls affect the image as it hits the baseline and reduces in vertical height, and the stretch will control the image as it rebounds from the squash. Let's start by looking at the squash controls. The main point of the squash section is to determine how much to deform the image vertically as it hits the bounce baseline. I'll bring our smiley to the first time it hits the baseline, and you can see that it is currently maintaining its round shape. That's because our squashiness control is set to 0. If I move it up to 1, you'll see that the smiley squashes down quite a lot. The actual amount squashed on any given bounce will depend on the downward velocity of the image when it hits the baseline. Since that velocity will slow on each subsequent bounce, the squashing will get less each time. If you feel you want more squash than the squashiness control can give you, you can use the squash multiplier to increase it even more. In addition to how much the image will get squashed, you also have control over how long it will take for the animation to squash and rebound to its original size. The amount of time the squashing action will take is also dependent on the velocity of the image as it reaches the bounce baseline. This means that each bounce will squash less than the previous and will also take less time to squash. The frames squash limit control sets a maximum number of frames for the squash animation to take, regardless of velocity. This is not a linear value, so you'll generally never reach the full number of frames set in this frame squash limit. For example, if I set the gravity to something crazy like 5, turn up the squashiness all the way, and then set the frame squash limit to something like 25, we can see each squash takes a long time. It looks like the first bounce starts at frame 2, and the squashing action is done by frame 22, for a total squash frames of 20. So that's pretty close to the limit, but it would take a lot more velocity to get closer to that limit. So with the velocity of the image and the frame squash limit determining the basic squash length for a given bounce, you can use the squash time factor to fine-tune the squash length. This is a nonlinear value. In this case, if I set squash time factor to a low number like 0.139, the squash time will be reduced in about half. Turning squash time factor to 0 is an easy way to turn off squashing altogether. We're going to put gravity back to a more reasonable number and find some other good numbers for squashing to show you the next control. Okay, the squash easing lets you choose to add an easing curve to the deformation of the image as it squashes. By default, it's linear, where each frame squashes the same amount. If you set it to easing instead, the image will ease in and out of the most squashed position, so that may give you a slightly more natural looking result. When animating with squash and stretch, you'll often compensate for the shrinking of an image in one direction by expanding in the perpendicular direction. That's what the squash bulge factor will do. When set to a non-zero number, the squash bulge will increase the width of the image proportionally to the amount decreased vertically. A value of 1 for squash bulge will cause the animation to maintain the total area covered by the image throughout the squash. For example, say a 100 by 100 pixel image is being bounced. That image would have 10,000 total pixels. If the squash bulge factor is set to 1, the squashing animation will maintain that 10,000 pixel total as it reduces the height of the image by increasing the width of the image to compensate. If the squashed image is reduced to 50 pixels, at that moment the image width would be increased to 200 pixels. If the full compensation feels unnatural, any value between 0 and 1 can be set for the squash bulge factor. Values over 1 will overcompensate for loss of area in the height, but this will often lead to an unnatural effect. Let's look at the stretch controls. Stretch is the increase in height of an image after a bounce, before it takes off from the baseline again. What actually happens is that when the image hits the baseline on its way down, it will squash down and then unsquash itself to its original size. Immediately after that, it will start to stretch out vertically beyond its original size, and the amount it stretches is controlled by these stretch controls. The stretch controls are mostly analogous to the squash controls. Stretchiness will determine how responsive the stretch is to the velocity of the animation. I'll set stretchiness to 1. Now if I go to a frame just after the squash has completed, you'll see the image height is back to its original size. This is where the stretch starts. Going to the next frame, we can see that the image is stretching, but hasn't left the baseline yet because it's still growing vertically. Then, by the frame after that, it's reached its full stretch, so it's taken off from the baseline and is on to the next bounce. You can go pretty extreme with the stretchiness if you want, including by using the stretch multiplier control, but it is limited by the velocity of the animation, just like the squash was. Stretch rebound factor controls how long it takes for the stretched image to return to its normal size. At a value of 0, it will snap back to its original height as soon as it is done stretching. At a value of 1, it will take all the time it can, only completing its rebound to normal size when it returns to the baseline and is about to squash again. That way, the image always has some subtle shrinking or growing vertically, which gives it some nice life. Note that if you have a large stretch, you may find that there may not be enough velocity for some bounces to ever actually get off the ground, so the image just looks like jello jiggling. Cranking up the stretch multiplier makes this easy to see. It's a pretty cool effect, but if you don't want it, you'll want to reduce the stretch multiplier or possibly the stretchiness. You can also use the stickiness control. This control is designed to help deal with the sticky feel of the bounce when the upward bounce can't overcome the stretchiness. It's particularly useful if you have a bounce that is reaching the end of its life and is bouncing low and fast, but not getting off the baseline because there's too much stretch. You can fiddle with the stickiness so at the low range, less stretch will be added, so the image will appear to still be bouncing rather than just acting like jello. The stretch narrowing factor behaves in exactly the same way as the squash bulge factor. It will reduce the width of the image proportionally to the amount of vertical stretch. And a value of 1 will maintain the same area of the image. I feel like pushing this past 1 can actually make the animation seem like it's a bit more extreme without being too cartoony. Motion blur often really helps when using the bounce tool, especially when you're using the squash and stretch options. Since motion blur is so demanding on my system, I found it best to apply after I've created the bounce that I want, and then I really crank it up. You can see how much nicer it looks. I've also found that conservative values for squash and stretch tend to look much better than larger ones. Now you have an understanding of the core controls for creating a bounce animation. What's left are some specialized options. Let's start with baseline timing. Baseline pause time is measured in frames, and it does exactly what it says. I'll put a pretty big number in here. As you can see, the animation reaches the bottom of the squash, and then it will hold there for the selected number of frames, and then start unsquashing and moving into the next bounce. Min time at baseline is here to solve a problem. The bounce animation is kind of a simulation that is run based on the parameters that you've given it. Because of that, sometimes the actual moment where the image gets to the baseline is missed. It's most likely to show up if you have no squash set up for the animation. In this case, you'll see moments where it looks like the bounce is happening too high sometimes. You can use the min time at baseline to make sure that the image always reaches the baseline for at least 1 frame per bounce. This is the default, and there's probably no reason to ever change it. Next up is my favorite section, the somersault section. This allows you to rotate your image in precise timing with the bounce without using keyframes. Half turns per bounce controls how many somersaults the image does during each bounce. Odd numbers will leave the image inverted from the previous bounce. If we start with 2, the image will do 1 full somersault each bounce and will land upside up each time. I find this looks a bit better without any stretch, so I'll turn off the stretch for this. If you want the image to only get around halfway each time, you can set this to 1. You can go much higher as well to get a spinning effect. Any even number will make the image land right side up, and odd numbers will cause the image to alternate landing right side up and upside down. Rotation will stop when the image is squashing to enhance the feeling that the image is doing discrete flips. Setting this control to a negative number will make the somersaults go in a counterclockwise direction. The somersault time factor controls how much of the available time it takes for the image to perform the requested number of turns. The total available time is the moment the image takes off from the baseline to the next time it lands at baseline. Setting the somersault time factor to 1 will use up all the available time. If you want the somersault to complete around the middle of the bounce, set the somersault time factor to 0.5. That sums up the controls for creating a bounce animation. But there are several more advanced things that you can do with the data once you've built your bounce animation. The first thing to do to work with the data for your animation is to save it locally inside the node. This will allow access to the data for the other functions that need it. Do that by pressing the Save Bounce Data button. You'll get a confirmation that the data has been saved. The first thing you can do with the data is to create a polygon with it. To do that, press the Create Polygon button. The bounce itself is limited to the y-axis, but the polygon that's created is stretched across the frame for better visibility. So, You can merge this over a colored background and get a visual representation of the path that the bounce follows. Once this polygon is created, it has no connection to the bounce tool, so you can move it anywhere in the comp or even copy it to other comps with no regard for the original bounce tool. Just for fun, I'll animate it here so that it follows the bouncing smiley. You can also export the bounce data. To do this, click the Export Bounce Data button. Enter the path of the file you want to save. Make sure to enter the full path with the file name, ending in .csv. Click OK, and a CSV file will be created that will allow you to use the data in any other program you wish. Here I've taken the exported data, and using this simple script, I've imported it into Blender to animate a sphere object. Now we have our bounce in Blender, including our squash and stretch. I've included the script with the Anim Toys tool pack for your reference. There are also two helper nodes that can be used in conjunction with the data saved from the bounce node. The first is the bounce save node. You can use this node to duplicate the bounce animation you've created in the bounce node and not have to do the calculations for every frame. I'll create a bounce save node here. Like the bounce node, it's going to need an image to work with. I'll bring in this box image. Now I'll merge it into the main comp. I'll add a transform node so I can move it out of the way of the smiley. Now I can set up the bounce save node to use data from our original bounce tool. The first thing to do is to make sure we have the correct name of the bounce tool we're trying to copy in the source bounce field. It defaults to bounce anim, which is the same as the default name of the bounce node. So in most cases, it will be correct. Once that is set up, make sure that you've already clicked on the Save Bounce Data in the main bounce node. Once you have the confirmation that the data has been saved, you can click the Get Bounce Data in the Saver node and it will be transferred over. At this point, you'll get confirmation that the data has been transferred over to the Saver node. You can get the data from the original bounce node anytime by clicking the Get Bounce Data button again, but it will only retrieve the last data saved in the bounce node. Once you have saved the data in the bounce save node, any changes made in the original bounce node will not be reflected here unless explicitly requested. Okay, now that you've got the data, you can apply it to the image that's being input into the node, in this case, our box. This can be done with these 6 buttons here. There are 3 types of data that can be used: position, or center point, angle, and deformation, or squash stretch. Each of these sets of data can be applied to the node as an expression or as keyframes. Let's look at the expression first. If I choose Set Center Point Expression, you'll see that an expression is added to the center point control on the node, and now the box is following the path of the smiley face exactly. That's because when we copy the data from the bounce node, the height position for each frame was transferred over to the bounce save node, and the expression we just wrote is reading the saved data and returns it as the result of the expression. This is very clean and simple, and it works great. The only problem with this method is that if you want to use motion blur, it will not work, because motion blur calculates values between frames to create the blur, and there's no data there to do that. So if you want motion blur on your saved bounce, use the second option. To do that, first reset the center point to default. This ensures that Fusion doesn't get mixed messages between the expression and the keyframes. Then we can select the Set Center Point Keys button. As you can see, it's a bit messier, since now there's a keyframe on every frame of the comp, but if we turn on motion blur, it works because Fusion is able to interpolate between the keyframes to create the blur. We can quickly add the keyframes for the angle and the deformations in the same way. And now the entire bounce animation matches the original. The nice thing about the saved bounce is that it does not need to continually recalculate the bounce simulation, so you might even want to make a practice of using a bounce save node for your bounce once you're happy with it, and bypassing or deleting your primary bounce node to save on render time. Of course, the bounce save node is also useful if you want to have a lot of bounces in your comp that all behave the same way. Finally, we have the bounce stretcher node, which is a customized version of the time stretcher. With it, you can synchronize aspects of other nodes with the data from the bounce node. We can use the box image again to demonstrate. The transform node will define the full range of change I want the box to take. To set that up, I'll start at frame 0. I'll add a keyframe to size and set it to around 0.2. Next, I'll go to the end frame and change the size to something bigger, say 3. Now if I play through, the box just grows bigger throughout the comp. The bounce stretcher node will use the bounce data to manipulate when each frame is displayed. Let's add in a bounce stretcher. Now that we have the bounce stretcher in place after the transform node, we need to get the data from our bounce tool. Just like the bounce save node, we have a source bounce field which needs to be filled with the name of the bounce node we want to copy the data from. Again, the default is correct here, so all we need to do is press the Get Bounce Data button. Once the data copy is verified, we have several ways to stretch the incoming data from the transform node. Just like with the bounce save node, we can do this with expressions or keyframes. Because I'm going to want motion blur, I'm just going to use the keyframe versions. Each of these will set keyframes on the source time control of the bounce stretcher. This is kind of a hard concept to explain, so if you're not familiar with the time stretcher tool, I'd recommend learning about that before trying to use this tool. But technically, you don't have to, because you can just select the button you want and you're good to go. I'll start with the height keys button. In our case, this will make the box bigger the higher up the smiley is in the frame. The smiley starts at its highest point at frame 0 before its initial drop, and the box is at its largest value. As the smiley reaches the bounce baseline position, the box becomes its smallest size and stays that way until the smiley takes off from the baseline again. The Set Progress Keys button will set keyframes that synchronize the size of the box with the progress of each bounce. So, if I find a frame where the smiley is at baseline and has completed its squash, that's where the bounce node considers the next bounce to begin. So that's where the box is at its smallest. Then as the bounce progresses up, then back down to hit baseline again, the box will get bigger and bigger until the smiley completes this bounce. Then on the next frame, it will get small again because it's starting a new bounce. Let's try the last kind of keyframes, which are the wave keyframes. Now as I play through, you'll see the box get bigger and smaller as the smiley bounces. There's a subtle difference between this option and the height keys option. The height keys are motivated by the absolute height of the smiley, whereas the wave keys are motivated by the relative position of the smiley in the current bounce. So when the smiley reaches the top of any bounce, the box will reach its maximum size, regardless of how high that bounce is. It's subtle, but if you're looking to sync motion with the bounce motion, you'll probably want to use the wave keys. And if you're trying to sync with absolute position, then the height keys will be the way to go. Thanks for taking the time to learn about the bounce tool in the Anim Toys tool pack for Blackmagic Fusion. Use the link in the description to get the Anim Toys pack and check out these other videos to learn more about the tools.